Alright, this is the start of your Unit 10 review. I'll put this in several videos and we'll start with problem 1. So it says put f of x equals x cubed minus 4x squared plus x plus 1 all over the quantity x plus 2 in proper rational form. So proper rational form means that the degree of the numerator is less than the degree of the denominator. So right now we have this x cubed minus 4x squared plus x plus 1 all over the quantity x plus 2. So the degree of the numerator is 3, the degree of the denominator is 1. So it's not in proper rational form. We do long division to fix that. So we'll do that here. And once we do that, it will be in proper rational form. So I need an x squared here to give me x cubed there. X squared times 2 is plus 2x squared. We always subtract with long division, so flip the signs. The x cubes cancel. Negative 4x squared minus 2x squared, negative 6x squared. Bring down the plus x. X times what gives me negative 6x squared? That would be a minus 6x. So negative 6x squared there. Negative 6x times 2 minus 12x. We always flip the signs, so this goes to a plus. X plus 12x, 13x. Bring down the plus 1. So what times x gives me 13x? That's plus 13. Scroll down a little here. So that's 13x there, and plus 26. 13 times 2 is plus 26, positive 26. Subtract that. 1 minus 26, negative 25. Nothing left to bring down, so this is my remainder. So minus 25 over the quantity x plus 2. So now it is in proper rational form because the only rational portion, the only fractional portion, is in proper rational form. Degree of this numerator is 0. The degree of the denominator is 1, so that it's bigger on bottom. It is in proper rational form. So this original problem is the same thing as this. It's equivalent, but now the one boxed in red here is in proper rational form. All right, let's go to the second problem on your review. All right, problem 2 says identify domain holes in all asymptotes of x cubed plus 8 over x squared minus 9. So we'll write it with a horizontal division bar here. All right, so we'll start with the horizontal asymptote. That's what we usually do, following our list here. Horizontals, we use Bobo Botten eats DC. So is it bigger on bottom, bigger on top, or are the exponents the same? This one is bigger on top, so there is no horizontal, none there. We have next, we will have a slant because it's 1 degree bigger on top than bottom. And following our list that we've been using throughout the unit, the slants occur when the numerator is 1 degree higher. So we will have a slant. We'll find that through long division in a moment. So we'll keep working here. We've got a vertical asymptote, and we need to check for holes as well. So we need to fully factor this first. The top is going to factor using sum of 2 cubes. So that's going to be x plus 2 and x squared minus 2x plus 4. So that's the pattern for sum of 2 cubes. And then the bottom is difference of 2 squares, so x plus 3, x minus 3. So none of the factors cancel, so that tells us that we have no holes. Remember from using our list here, holes factors that cancel in the numerator and denominator, none of them cancel. So vertical asymptotes are coming from factors that do not cancel in the denominator. So that's x equals negative 3 and x equals positive 3. Remember, between your factor and the answer, you write down the signs will be opposite because you're setting these factors equal to 0 and solving. And again, from your list, vertical asymptotes, factors in the denominator that do not cancel with factors in the numerator. All right, and they also want domain on this. So domain is x cannot equal anything where you have a vertical asymptote or a hole. So it's coming from these factors in the denominator. So x cannot equal 3 and x cannot equal negative 3. Everything else is okay. So now let's find the slant using long division. So we'll have our x cubed plus 8 and we'll divide that by x squared minus 9. So what times x squared gives me x cubed? That's an x. So that's an x cubed here. X times negative 9 would be minus 9x. I should have wrote a 0x term there, but that's okay. So I would have negative 9x left, and then I would have to bring down the plus 8. Okay, you can't subtract these two from each other. So, and actually this would be a positive. I need to fix that. Because when you do your long division, you have to switch the sign. So it's actually a positive 9x there. So that would be my remainder actually. So plus 9x plus 8 all over x squared minus 9. So the slant is everything in front of the remainder, so that would be y equals x there. And that is going to be it for that problem. That answers everything. The domain, holes, and all asymptotes. So let's move on to problem 3 next. Alright, now for problem 3 on your Unit 10 rational function review. Write the function that produces this graph. So this is the parent function just transformed. So it's all about tracking the horizontal and vertical asymptotes. So this vertical asymptote is at 1, 2, 3, 4, right through here, like this. So it's been shifted right 4. The horizontal asymptote has been moved down 1, 2, 3, so down 3. Remember the vertical asymptote starts here on top of the y-axis at x equals 0, and the horizontal asymptote starts on top of the x-axis at y equals 0, and we just track how they're transformed. Normally the graph should be in the upper right and lower left portions, but this one is opposite of that, so it's also reflected. So when we write our function, it needs to have those transformations done to it. So we'll put a negative in the very front for the reflection, and then we'll have 1 over, to move it right 4, we need a factor, or we need the denominator to be x minus 4. And then to move it down 3, we need a minus 3 out here to the side. So altogether, f of x equals negative 1 over the quantity x minus 4 with the minus 3 out here. So this was the down 3, this is the right 4, this is the reflection. So that's it for 3. Let's go on to problem 4. Alright, problem 4 on the review. We're looking at these tables to determine where we have vertical asymptotes, horizontal asymptotes, and or holes, and then sketching the behavior near that asymptote. And if we have a hole in the graph, we have to give both the x and y coordinates. So looking at number 4, we notice that x is approaching 4 here, x is approaching 4 here, and the f of x values are approaching positive infinity here and negative infinity here. So going off of this left-hand table, this is saying that x is approaching 4 as f of x approaches infinity. This table on the right is telling us that x is approaching 4 as f of x approaches negative infinity. So the f of x values are approaching either positive or negative infinity. So what that tells us is that we have a vertical asymptote at x equals 4. So VA at x equals 4. And as f of x is going to positive infinity over here in this table, we're approaching an x value of 4 from the left-hand side. So it looks like this. And then this part of the graph is telling us as the y values goes to negative infinity, we're approaching 4 from the right-hand side. We're at 4.5, then 4.1. So that part of the graph would have to look like that. So that's what they were looking for on number 4. Let's look at number 5 next. All right, now for problem 5. So let's analyze the tables here. On the left table right here, x appears to be approaching negative 1, and we need to, I'm taking this part out. I'm not sure why this resource puts those values there. They don't need to be there. So let's start over here. So x is approaching negative 1 and f of x is approaching 3.8. So this table is telling us x is approaching negative 1 as f of x is approaching 3.8. And over here on this table, x is approaching negative 1 also as f of x is approaching 3.8. So x is approaching the same value, y is approaching the same value, need to put the decimal there. So that tells us that we have a hole in the graph at -1, 3.8. So we'll put that in here. We'll put a coordinate plane real quick, graph that. And a hole in the graph at -1, 3.8. So -1 and then 1, 2, 3, 4. So approximately right here. And over here we're approaching from the left hand side, and our x values are -1.5, -1.1, like that, and the y values are going up, so it's looking something like this. And then this section of the graph, we have our x values are approaching -1 from the right hand side because we're at -0.5, so somewhere right in here, and then -0.9, like that. And our y values are increasing up to the 3.8, so it looks something like that. And that, we'll call that good on that sketch. But what we want to see here is the x and y values are both approaching a specific number, so that is indicative of a hole in the graph, as opposed to the previous one where one of them, either x or y, is going to either positive or negative infinity. Those give us either vertical asymptotes or horizontal asymptotes. If it approaches a specific value, they want you to see that there is a hole in the graph at the values that are being approached by both x and f of x. So we'll call that good on this video, and we'll pick up with problem 6 in part 2. For this question, we do need to write that out, that we have a hole in the graph. We wrote vertical asymptote here, so we need to write that here. So they want us to list that. So there is a hole at -1, 3.8. So that actually answers the question. They wanted the sketch and us to list that there is a hole there. So that's it. We'll move to question 6 next.